Hi, good evening. Welcome to Made Easy Gate Through Questions GTQ. My name is Prasad. Today we will see some expert questions in theory of computation and comparison. As usual, I display the question, I'll give you some time, you try them, then I'll give you the solutions. Okay, let's start. First question, which of the following is true? It is MCQ. Every context-free language is also a regular language over unary alphabet. Next option B, every context-sensitive language is also a CFL over unary alphabet. And C, a recursive language is not a regular language. And D, none. Try. Wow, very good. Every one of you giving the right answers. Okay, good. Unary alphabet means sigma is only one input symbol. Sigma equal to suppose say A. Okay. So in our unary alphabet there is no comparison. So no comparison. So it is a context-free language. If it is a context-free language, means no comparison, then every context-free language also will be a regular language, because in push-down automata what we do, we'll push and pop operations we do, but our in single input alphabet, so what we do? So if it is a CFL, is always a regular language, so it is a true, because here it is unary alphabet. Next, come to this one. Option B, every context sensitive language means if it is a context sensitive language, then it is also a context free language over unary alphabet. Same sigma equal to A, unary alphabet I am taking, and L equal to A power n square, or see, this is context sensitive language but not a context free language. So it is given that every context sensitive language also a CFL over. So this is a false statement. Next, come to the option C. A recursive language is not a regular language. So what is this here? If the question is given that every recursive language is not a regular language, then it is a false statement. A recursive language can be regular language. Suppose a language is regular, a regular is also recursive, then a recursive will be a language, a regular language. A recursive language can be a regular language, but it is given that not a regular, because here it is given that generally if every recursive language is not regular, then it is true, but it is given that if not a regular, it is false. So what is the question here? Which of the following is true? Answer A. Next question, which of the following is oblique or CFL but not regular? So it is MSQ. Try this question. Second question. Try this question. See, the question is CFL but not regular. CFL but not regular. So only two persons are given answers, the correct answers, Ansu Mahapatra and Andretti Asuna, I think. Okay, your answer is correct. Ansuya Mahapatra, your answer is correct. Good. Madhav Mishra, very good. Okay. Kundan Kumar, good. Okay. I'll do this question. Which of the following is CFL but not regular? Here A power n. Many of you has given us A also, okay, but it is not correct. A power n, B power mn. M is also a variable. If m is 1, then A power n, B power n. If union, if m is 2, A power n, B power 2n. Then m is 3, A power n, B power 3n, union, so on. This is infinite. Whereas here option A, this is option A power n, B power mn, m is also a variable, and this n must be equal. So if m is 1, then A power n, B power n. If m is 2, m is 3, m is 4, so on. So whereas here this is CFL, A power n, B power n, push A when B comes pop, union. Push for every A, push 2 A's when B comes pop, CFL, union, this is CFL, union, so on, infinite union. Infinite union is not closed any language. So this is not CFL, okay. So which of the following is CFL but not regular? So this is not the correct answer. Next, A power m, B power n, coming to the option B. I think you understand this first option. So it is not a CFL. Coming to the option B, A power m, B power n. So powers are different, but there is a relation here. Whenever relation, it is not a regular. And this is m equal to 3n, one time relation, and m equal to 3n plus 5. Yes, we can 5, this 5 we can check by changing the states and relation. It is CFL but not regular. Next, A power m, B power n, m plus n equal to 7k. This is m plus n, the length of the string, multiple of 7, divided by 7. It is regular. A regular is also CFL, but question is not regular. Okay. Next, A power n, B power n, C power p. All the powers are different, no relation. But here we have the relation m not equal to n, means the number of A's is not equal to number of B's. So relation is there. If m not equal to n, then p equal to 3k, means the number of C's must be multiple of 3. That can be, you can check by changing the states. So if m not equal to n, the relation is there. So whenever relation, it is not a regular, but it is a CFL. So CFL but not regular. So simple question, but it's, many of you should give the wrong answers. Okay. So here What is the question? Which of the following is CFL but not regular? B and D answer. Okay, good. You have tried. Next we will go for next question. The minimum number of states of a DFA or set dual compound that accepts all strings that are divisible by both 3 and 4 is. Numeric analysis question, you just try. So, easy question, but many of you giving the wrong answer. So, I told you in the class these kind of questions, how to solve the questions, I told you. But that will give you, everyone is giving the answers 12. 12 is right answer, is a DFA, but it's not a minimized DFA. Just you recollect, I told you it is just construct the DFA with the 12 states, but if you want the minimal DFA, you have to go for minimization process. So, the 12 states is a DFA, you will get perfect answer, but it may not be the minimized. Minimized, to get the minimized, you have to go for the minimization of DFA. So, 12 is not the right answer. Nidhi Sinha and Akshay, you please check your answers. Okay, so it will take some time. Okay, it is so the question, if I have not asked this minimized DFA, then 12 will be the answer. Then any state can be the answer. Okay, any value can be the answer. But here I have clearly mentioned that minimized number of states. Okay, so I will try this question. I didn't get this answer till now. Very good, Ritusri and Upalab Rajak. Yes, very good. Your answer correct. Good. Good. Aman Kurana, very good. Anusui Mahapatra, very good. Good. Raman Singh, very good. Okay, I'll try this question. So, in general, every one of you know that. So, 3 and 4, divide by 3 and 4, it will give 12 states. So, 12 states will be there, and both 3 and 4, then 12 states will be Q0 to Q11. So, Q0 to Q11, 12 states are there, and divided by both 3 and 4, Q0 will be the final state. Okay, and inputs 0 and 1. Simple, I told you the shortcuts technique. So, Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, Q11. Then repeat this procedure. Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, Q11. Okay, this is the structure. This is the DFA. From this we will find the minimized DFA. How to find the minimal DFA? Just first step, delete the unreachable states. Of course, there are no unreachable states. Then after that, separate final and non-final states. Okay, first one S1. There are no unreachable states. So every state will be there. Q0 to Q11, 12 states will be there. After that, so what is the next step? Separate final and non-final. What is the final? Only one state is final, Q0. So I have separated Q0 and remaining the states. Okay, after that, next step, separate those states directly going to the final states. So here, what is the final state? Q0 is the final state. Where is Q0 as output? Here Q0 as output in this state only. So Q6 is directly going. So that is the reason I have separated Q6. Okay, after that, you know that. So check 0 equivalent and 1 equivalent. 0 equivalent and 1 equivalent. S4. So Q0 anyway it is separated. Q6 it is single state. Then I am checking Q1 and Q2. Q1 and Q2. Q1 on 0 it is going to Q2. It is in this set. Q2 on 0 it is going to Q4. So both Q1 and Q2 are 0 equivalent. If they are 0 equivalent, check for 1 equivalent. So Q1 on 1 it is going to Q3. And Q2 on 1 is going to Q5. So Q3 and Q5 both are here only. So Q1 and Q2 cannot be separated. Okay. Now I will check Q1 and Q3. Q1 on 0 Q2 is in this set, and Q3 on 0 Q6. Okay, I repeat, I am checking Q1 and Q3. Q1 on 0 Q2 which is in this set. Now Q3 and 0 Q6 in this set. So Q1 and Q3 are not 0 equivalent. If they are not 0 equivalent, then I will separate Q3 as a different set. Then Q1 Q4. So Q1 Q4, Q1 on 0 Q2, Q4 on 0 Q8, Q2 and Q8 are in the same set. Then Q1 on 1 Q3, Q4 and Q9, Q3 and Q9 in the same set. So Q1 Q4 you cannot separate. Similarly Q5 you cannot separate. Simple. So you need not to do everything. See what is the here Q6. Wherever Q6 as output, Q3 is having Q6 because Q6 already is separated. In these states, which state is having Q6 as output? Q6 is having here, and where else? Here. So Q3 and Q9 will be separated. You need not to check from Q1 to Q10, Q11 everything. Okay. So Q3 is having 0 Q3 on 0 Q6 and Q9 on 0 Q6. As Q6 already separated, so Q3 and Q9 we write in a different set, and Q1, Q2, Q4, Q5, Q7, Q8, Q10, Q11, these will be in one set. Okay. Now S5. Anyway, Q0 is separated already, Q6 already separated. Now I will check Q3 and Q9. First I will check Q3 and Q9. Q3 on 0 Q6 here, Q9 on 0 Q6. So both Q3 and Q9 are 0 equivalent. Now we will check for one Q3 on 1 Q7 is here, Q9 on 1 also Q7. So both Q3 and Q9 are 0 equivalent and 1 equivalent. So you cannot separate Q3 and Q9. Now check Q1 and Q2. I am checking Q1 and Q2. So Q1 on 0 Q2 which is here, Q2 on 0 Q4 which is here. I repeat, Q1 on 0 Q2 on 0 Q4. Both Q2 and Q4 in the same set, therefore Q1 and Q2 are 0 equivalent. Now I will check for 1 Q1 and Q2. Q1 on 1 Q3 is here, Q2 on 1 Q5 is here. So one is in this set, the other one is in different sets. So therefore Q1 and Q2 are not equivalent. Therefore I will separate Q1 and Q2. Similarly, if you do Q1, then Q4, then Q7, then Q10 will be in one set, and Q2, Q5, Q8, Q11 will be in another set. You can check. Suppose I am checking Q2 and Q5. Q2 and 0 Q4, Q4 is here, and Q5 and 0 Q10 is here, both are 0 equivalent. Now I will check for Q2 and Q5 1, Q2 and 1 Q5, it is here, Q5 and 1 Q11, it is here. Therefore Q1, Q4, Q7, Q10 is one set, Q2, Q5, Q8, Q11 another set. The same next if you repeat the same procedure S6, you will get the same sets only. You try, you will get the same set only. Okay, therefore here this is one set and another set, and this is one more set, third one, this is one more set, fourth one, this is one more set, fifth one. So if you do the same procedure, you will get the same 5 sets. So 1, 2, 3, 4, 5 states is the answer for this question. 5 is the answer. Okay, good. There is no shortcut. So the shortcut is initially you will get the 12 sets. From the 12 sets you have to apply this procedure. Okay. So don't do any mistake. So give the proper answer. The regular expression over a comma b for the set of all strings that starting with a and not ending with a. Not ending with a means what? Simply ending with b. Not starting with a and ending with b and having even number of a's. Okay, try. I am waiting for the answer. Fourth question. Fourth one. Good. Madam Mishra, Sardak, Raman Singh, Akshay, Arsjain, Ritushree, wow, Anusri, Mahapatra, Soumya Nandi, very good, very good. Aman, yes. Divyansh, Saini, very good. Very good. 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 This is a simple question. This is a very simple question. So starting with A and ending with B. Starting with A, and ending with B, and it must have even number of A's. Even number of A's. Okay. So if you go for B option, it always gives even number of A's. Even number of A's plus 1A will give you the odd number of A's. So this is not correct answer. Okay. Next, here this is this one. I'm going for D option. So here A followed by, it gives both even and odd. So it will give all even and odd. So this is not correct. So options either A, because starting with A and ending with B. Here also starting with A and ending with B. It can have any number of B's. Okay, and A even, here also A and A even. So inside also it gives even number of A's, and here also inside gives even number of A's. So either A or C. What is the right answer? So here A is not correct. Why? Because I want A, B, A. Because here it is right valid string starting with A and ending with B and having 2 A's, even number of A's. Okay. So here this A I will get from this option, and AB I will get from this, and in between A and A I want B. How do I get the B? If I want the B, I have to go inside. If I go inside, I will get the 2A. So that is the reason this is not the correct. Whereas, see this one, A, and from this A, B, so we got this, and B, from B star you can take any number of base. So right answer is fourth one, C. Very good. So many of you have given the answer C. Okay, so we go right. Next one. Try this question. This is MCQ. Try the fifth question. Fifth one. I am getting different answers for fifth one. Madhav Mishra, your answer is right. Akshay, your answer is right. Sardak Paul, your answer is right. Crazy. Who is this crazy? So your answer is also right. Yes, Yogita Chand is good. Aman Kurana, right? Yeah, Kesagor. Good. Yeah, very good. Ritusri, Kesagor, very good. Anshi Mahapatra, good. Okay guys, you are getting this answer, very good. So you know that initially the final state, and if you go and we can come back, so the answer is 0 plus x whole star. 0 plus x whole star. And this is anyway dead state, so leave it. 0 plus x whole star. So 0 plus, just go 1, and in this, at this state, this is 1, again this you can come back. So I can write it as 1 plus y whole star. 1 plus y whole star. What is 1 here? I repeat, this is 1 and this whole star. 1 plus, what is this? 1, this is 0 star, and followed by 0 whole star. Okay, I repeat, 0 plus x whole star, x is 1, again this is 1 plus 1 0 star 0 whole star. The machine stops here. Then if you want to go to this state, it must have 1, then 0 star, then from here to here 1 whole star. This is the answer, but this is not given. This is not given. So what shall we do? Let me check. And here, see, there is no answer. So in this, I will take one common. In both, I will take one common. If I take one common here, epsilon plus this will be 0 star 0 and whole star. Epsilon plus r star, or epsilon plus r star r. This will be r star. Epsilon plus R star is R star. So 1 0 star whole star, and here it is 1. Here it is 1 0 star 1, and here 0 plus. So this is the answer. Do we have this one? 0 plus 1 followed by 1 0 star whole star, 1 0 star also. Option is B. Answer is B. So very good. Many of you have done this question. Good. This is MSQ. Try this question. Which of the following is oblique or true? If L1 union L2 is regular, then at least one of them must be regular. If L star is not regular, then L is not regular. And if L1 and L2 is regular, then, and if L1 is finite, then L2 must be regular. If L1 and L2 is not regular, then at least one of L1 or L2 is not regular. I didn't get the question. I didn't get the answer from anybody till now. Only Sarbek Paul, your answer is correct, and the rest are not giving. Abhinav, okay, Saloni Kumari, which is good. Pratik Singh, good. Swaminandi, good. Upla Prajak, very good. Anshu Mahapatra, very good. Good, good guys. Yeah, very good. Let me explain this question. Which of the following is true? If L1 union L2 is regular, then at least one of them must be regular. Not necessary. I have given this property, okay, conversion of regular properties I have told you. In that I told you, suppose L1 is A power and B power n, and L2, L1 bar, that is sigma star minus L1. So both are not regular, but their union sigma star, it is regular. So if L1 union L2 is regular, then at least one of them must be regular. No, this is not regular, this is not regular. None of them is regular, but their union is regular. So here, if L1 union L2 regular, then at least one of them must be regular, so need not be regular. So this is a false statement. Okay, next one. See this, if L star is not regular, then L is not regular. You know that if L is regular, implies L star is also regular. You know very well, regular language are closed under, cleans closure. This is one-way theorem. If L star regular, then L need not be regular. I have given you an example also in the class. So this is one-way theorem. One-way theorem always, the contrapositive is always true. So what is contrapositive? Implies if L star is not regular, L star is not regular, implies L is not regular. L is not regular. Okay. So if L star is not regular, then L is not regular. It is true. It is false. Okay. B is true. Okay. Next. Come to this one. If L1 intersection L2, the option C, is regular, and if L1 is finite, every finite language is regular. Okay, and then L2 must be regular. Suppose L2 is some a power n b power n greater than or equal to 0. This is CFL, and L1 equal to b star a star, b star a star. This is regular. Okay, I will give you the finite. So I'll give you some finite language. Suppose A, then AB. Okay, suppose this one. L1 equal to A comma AB, it is finite. Every finite language is regular, and this is a power n b power n greater than or equal to 0. Here what is this? Always number of A's must be equal to number of B's. This is regular and this is not regular. And what is L1 intersection L2? L1 intersection L2 is only AB, which is regular. So L1 intersection L2 is regular. If L1 is finite, then L2 must be regular. No, it is not regular. So it need not be regular. So this is given that must be regular, which is a false statement. Then come to the last one. If L1 is L2 is not regular, then at least one of the L1 or L2 is not regular. So you know that if L1 and L2, if L1 L2 are regular implies L1 intersection L2. Intersection is regular. Okay. So this is also one-way theorem. One-way theorem. What is its contrapositive? Implies L1 intersection L2 complement is not regular. Complement is not regular. Then what is its complement? Implies L1 and complement are L2. Okay, not regular, or means one of them. So here, if L1 is L2 is not regular, then at least one of L1 or L2 is not regular. So this is true. So answer is B and D. Okay. So sixth one. Next. Very simple question, direct. I think every one of you can give the answer within seconds. This question, sixth question. So I have prepared in a moderate level the questions. Good. Very good. Okay. I'll go to the solution. I don't want to waste your time because this is very simple question. If L is recursively enumerable but not recursive, then L bar is not recursively enumerable language. Okay. If L is recursively enumerable, its complement may or may not be RE. When L is recursive enumerable but not recursive, then 100% its complement is not RE. So L bar is not RE, it is recursive. Option A is wrong. Recursive enumerable, wrong. Okay, not recursive. It is not completely right answer. Maybe recursive, never true, never true. Maybe how can, when L is recursive but not recursive, its complement never be RE. Maybe recursive is wrong statement. So among these, the best, actually the best answer is not RE. So among the options, you have to go to the best, choose the best answer. The best answer is not recursive. So answer is C. Okay. Very good. So this is also simple. So make it fast. Match the minimum pumping length of the languages represented by the regular expressions with the list B. Please mention the question number. And so Rohit Kumar, Saloni and Akshay, which one you are giving the answer? Oh, Sohana Sharma, good. Ishwar Mahapatra, good. Akshay and Saloni, please check your answers once. Soumyanandi, good. Raman Singh, Rohit Kumar, Madhav Mishra, Ritushri, very good. Okay guys, Aman, okay, very good. So Saloni, check your answer and tell me. Good guys, okay. So simple question. So I have told you the different rules in the class. Okay. Here this is infinite language. So the smallest string is 111. So the least length is 3, then 3 plus 1. So for this the MPL is 4. How it can be 4? So take any string 1011, the string of length 4, and you just pump this 0 any number of times. 0 times, 1 times, 2 times, 3 times, all will be in this language. So this answer is 4. Okay, next come to the second one. A plus B whole star, AB, A plus B whole star. Here also the small string AB, the length is 2, 2 plus 1, 3. So you take any string A, B, B, then you pump this, it will give the all the strings. Okay, whatever the strings it generates, they will be in this language. Okay, next. This one here, union of two languages. When you have the union of two languages, then MPL of languages will be maximum of MPL of the two languages. Now here AB star B whole star. So here what is the MPL for this language? The here A B B. This will be the string, and if you pump this, you will get the MPL. So answer is 3 for this language. Answer is 3 for this language. And here this is a finite language. The finite language MPL will be the maximum, the MPL will be the length of the maximum string plus 1. What is the maximum here? Maximum string is only 1, so 4. Then 4 plus 1, it is 5. Here it is 5, here it is 3. So what is the maximum of 3 of comma 5? It is 5. Next, A star, what is the small here MPL? MPL A star is 1, because epsilon is the smallest string, epsilon plus 1. So what is the string here? A. You pump A any number of times. So here it is 1. And here AB whole star, the smallest string is epsilon. Epsilon length is 0. 0 plus 1 is not right the answer. Here the MPL of AB whole star is AB only. Here AB. Now you pump any number of times. So what is the length of this one? 2. So MPL of AB whole star is 2. So here it is 2, here it is 1. So 1 comma 2. Which one is the maximum? 2 is the maximum. So P is 4. What is that? C. And Q is 3. What is that? B. So P is, okay. Now look at this. P is 4, which is this is P, and this is Q, and this is C, and this is S. So PC, BQ, and what is 5? 5 is R. Okay, RD and SA. So answer is D. So simple question. Answer is D. Sir, if in R option, okay, the finite string will be ABB, okay, then will be the 4 will be the answer. Okay, Ishwar Mahapatra. MPL of third one. MPL of third one. See, this is third one. Here the string is, take the ABB, you just pump any number of times. So what is the length here? The length of the string is 3, and it is here AABB is not the string of this language. Okay, so it is different language and only one string. And what is its length? Length of the string plus 1. So this is 5. So here 3 and that is 5. 3 comma 5. Maximum of 3 comma 5 is 5 is the answer. Okay, next. See, the minimum pumping length, so the string of the string of length equal to MPL need not be in the language. I have explained you this question clearly in the workbook. One question we have, so that is the previous question. There I have explained you very clearly. You can see that workbook solution. Which of the following is oblique or decidable? Very good, superb, good, very good. Is so every one of you try individually. So very good, I am impressed. So every one of you give me the right answer. So okay, I will go for the solutions. Next. Given a DCFG, deterministic quantitative language and deterministic quantitative grammar, G, whether L of G regular. See, regular languages and deterministic quantitative languages are decidable almost everywhere, except the difference between regular language and deterministic quantitative language in disjointness and also subset. Okay, the disjointness is undecidable. So here the regularity of deterministic quantitative language or DCFG is L of G is regular or not, it is decidable. It is decidable. So okay, it is clear, regularity of DCFL is decidable. Given two DCFs, deterministic quantitative G1 and G2, whether L of G1 equal to L of G2, equivalence of deterministic quantitative language or deterministic quantitative grammar, it is decidable. Okay, so subset and disjointness is undecidable in the case of deterministic quantitative grammar. So this is undecidable. Given DPDA, whether L of M equal to sigma star, DPDA means DCFL, completeness of DCFL is decidable. So only undecidable in disjointness and subset. Okay. So here, what is the question? Which of the following is decidable? So A, B, D is the answer. Good. So try this question. Which of the following is false? Given a regular grammar G, checking whether there exists a Turing machine M such that L of G equal L of T is decidable. Complement of RE language may be quantity free. Every non-regular language is accepted Turing machine, and set of all subsets of recursive language is uncountably infinite. UCI. It is MCQ, false statement. I didn't get any answer till now. Tenth question. It is MCQ, not MSQ. Oh, Saloni Kumari, ABCD. What is ABCD? So all are false. So many people are giving wrong answer, except one or So again, think about this question properly. Ishwar Mahapatra, just see the question, it is MCQ, not MSQ. Which of the following is false? Hey Vinay, it is MCQ, boss. Okay, so I'll go for this explanation. Tenth one. Given a regular grammar G, checking whether there exists a Turing machine M such that L of G equal to L of T means regular grammar gives what? Regular language. Regular grammar gives regular language. Every regular language, 100% it will be accepted Turing machine. Do you understand? Here a regular grammar is given and L of G, whatever the language generated by regular grammar, which is regular language will be accepted by Turing machine. So it is decidable. It is true. It is true. Then next one. Complement of RE language. Complement of RE language may be quantity free. Generally, complement of RE language is not RE. May or may not be, not closed. But complement of RE language may be RE. Na? May be RE. When it is RE, if it is recursive. If a language is recursive, then it is also RE, and it is also complement of RE is also RE. And I'll go from the down. So a regular language, complement of a regular language is also regular. Every regular language is also RE, and its complement is also RE. So every quantity free language is also RE. So here the complement of RE language will be context free. That is the wrong statement. Here see the question properly. Statement complement of RE language may be yes. So I will take RE regular language. Every regular is also RE. So regular complement is regular. That regular is also RE. So RE complement may be, and regular is also context free, na? Every regular. So complement of RE language may be context free. It is a true statement. Okay. Now next one. Come to C. Every non-regular language is accepted by a Turing machine. Non-regular. I will take non-RE. A language is non-RE. Non-regular. Non-RE. Non-RE is also not regular. So non-RE, a language is non-RE, L is non-RE, L is non-RE, then it never be accepted by Turing machine. Are you following? Every non-regular language, L is non-regular, which is I have taken non-RE. Non-RE never be accepted by Turing machine, but it is given that it is accepted by Turing machine, which is a false statement. Then next, set of all subsets of recursive languages. Set of all subsets of recursive languages. Recursive set of all recursive languages. Set of all recursive languages CI. Set of all recursive languages is CI, countably infinite. Countably infinite. The set of all subsets, that is 2 power CI. 2 power CI is UCI. I have told you in the class. Set of all recursive languages countably infinite. The set of all subset, that is 2 power CI, is UCI. So it is given that yes, uncountably infinite. It is true. So what is the statement here? Which of the following is false? So answer is C. 10th one, C. Very few has given. Okay, we will go for next question. This is Z0. B comma epsilon Z0, A comma epsilon X, B comma X epsilon, B comma X epsilon, A comma Z0 Z0, and A comma Z0 Z0, and this is. So the language accepted by given PDA. So don't do any mistake. Okay. So this is MCQ and MSQ. MCQ will have the negative questions, negative marking. MCQ will have negative marking. So think properly and give me the right answer. How you have done this much speed, the Ritusri? It's 11th question B answer. Very fast. Think properly. Think properly. Subhi Goyal, actually a regular, see the question properly, regular grammar, regularity not. So regular grammar, whatever regular grammar it is given, that is regular language, every regular language also accepted by Turing machine. So regular grammar to Turing machine, not Turing machine to regular language. Okay, the option it is given, so regular grammar to Turing machine. What about the others? 11th question. So this time is enough to solve this question. Good. So your answer is none. D is the right answer. D is the right answer. Here it is Z naught. Okay. Let me explain. Here you can see that the inputs are A and B. From initial state, it will go to it will do some operation if the first symbol is B. So the first symbol must be B. So what is B comma epsilon? Here means whatever the top symbol, you just replace with Z naught. Simply see, every time whenever the machine starts, in the stack, initial stack symbol will be there. So Z naught. So for B, it comes to the next state. Okay. After that, here A comes, what is the meaning of this epsilon? Whatever the top symbol, you replace with X. Whenever A comes, replace not replace, you just keep it and push the X. Here A comma Z naught, A comma Z. Here the meaning of the whatever A and top symbol, the present is A, whatever the top symbol, you just push X into the stack. Or when A comes, top is Z naught. When A comes, top is Z naught. You just go to the final, and after reaching the final, it stops. Okay. So suppose here A comes, then it will go to the final state. Z naught will be Z naught only. Once it go to the final state, it don't do any operation. And if the string is empty, it will be accepted. So the machine accepts BA. Okay, that is one thing. Suppose we will go for the other one. A comma epsilon. If A comes, replace with X. Again A comes and push X. Again A comes, push X. So keep on pushing X for every A. The meaning of this one is whatever the top symbol, for every A you keep on pushing X. After that, when B comes, the top is X, you delete it. When B comes, top is X, delete it and go to the next state. Again B comes, you can see this B comma X. When B comes, for every B, delete the top symbol X. So again this, and B comes, delete this. Okay, after that, if A comes, so here it must end with A, and when it must end with single A. When A comes, top is Z naught will be Z naught, it will go to the final state. So simply here, first symbol must be B, the last symbol must be A, and in between number of A's and number of B's must be equal, A power n, B power n, and n is greater than or equal to 0 because it accepts BA also. So many of you have given B option. So A power n, B power n is greater than 0, but here n can be 0 also. So what is the right answer here? None is the right answer. Okay. So D, good. Okay na? Next. So this is simple question. Make it fast. Which of the following grammar is LL of 1? Ishwar Mahapatra. So this is option D. Okay, 11th one. Now try that, solve the question. Don't give any wrong answers. So simple question. If the question is difficult or tricky question, you may give the wrong answer, but for easy questions, you please do this carefully. So most of the times we will do the mistakes in the easy questions only. Okay. So right answer is here. So D. D is the right answer. So very simple. Here first of this one is A. First of this one is A, and first of A is first of A. What is first of A? B comma epsilon. B comma epsilon. When epsilon is there, delete it. Come to right side. So union A. So B comma A. B comma A. So A intersection B comma A is A, which is not equal to 5. So implies not LL of 1. This is not LL of 1. First question. Okay. Next. This is single one, a single production you need not to consider, and take this one. This is first of A is A, and whenever epsilon you have to go for follow. Follow of A. What is follow of A? Follow of A equal to follow of A. Leave it. What is follow of A? Follow of A is first of B. First of B. Intersection. What is first of B? A comma epsilon. When epsilon is there, delete it and go to right side and follow of S. You need not to do everything, because already we got the common elements now. A intersection A equal to A, which is not equal to empty. Not equal to empty is not LL of 1. Okay. Next one. So this is not LL of 1. I'll go for option C. Option C. This is single, the single production you need not to consider, and this is B. B intersection epsilon, which is follow of A. Follow of A. Then what is follow of A? Follow of A, wherever A on the right hand side. Here on the right hand side, follow of A equal to follow of A, leave it. And here on the right side, what is the follow of A, which is B? So B intersection B is B, not equal to 5. Not equal to 5 means not LL of 1. So which of the following grammar is LL of 1? None is the answer. Okay. Next. This is easy question. So give me the perfect answer. MCQ. MCQ, not MSQ. So many of you giving the multiple answers for MCQ also. So see the question properly. Simple question. Good. Oh, 3 different students have given 3 different answers for 13 question. So which one is? So easy question. Madha Misra, what happened to you? Wow, I thought that this is very easy question, but many of you are giving different answers for this. Okay, I'll do this. A regular grammar is also linear grammar. Of course, it is true and can be parsed by LR of parser, LR of 1. How? A regular grammar can be ambiguous grammar. If an ambiguous grammar is never be LR of 1. So, and not LR of k, any ambiguous grammar. So, this is given that a regular grammar is also linear until here it is true and can be passed by LR of k parser, LR of 1 parser, which is a false statement. A false statement. Next one. An LA LR of 1 grammar may be LL of 1 grammar. An LA LR of 1 grammar, actually there is no relation between LL of 1 and LL of 1. Every LL of 1 is also LR of 1. And LR of 1 may or may not be LL of 1. But there is no relation between LA LR of 1 and LL of 1. If a grammar is LL of 1, it may or may not be LL of 1. If a grammar is LA LR of 1, it may or may not be LL of 1. What is given here? An LA LR of 1 grammar may be, yes, may be, it is true. Will be, if I instead of maybe, if I give will be, then it is a wrong statement. Then a left recursive grammar is not LR of 1. A left recursive grammar is not LL of 1. But it can be LR of 1. It can be LR of 1. It is given that not LR of 1, which is a false statement. Then SLR of 1 is more powerful than LL of 1. Actually, there is no relation between LL of 1 and SLR of 1. The grammar which can be passed by LL of 1 may not be by SLR of 1. A grammar which is passed by SLR of 1 may not be LL of 1. So there is no relation. It is given that more powerful, which is a false statement. What is the question here? Which of the following is true? B is the right answer. Okay? B. So many of you have given wrong answers in this question. Okay. So don't do these kind of mistakes in the examination, Yeshwar Mahapatra. So reading the question is very important. Reading the question properly. Okay? Next. Look at this. 14th question. Which of the following statement is oblique or true? I have given two statements. First one is LR of 1 grammar. Second one is about ambiguity. Fourteenth question. So these kind of questions you must have some patience. So do it properly. So I told you, when the question is easy, you have to do it very carefully, because most of the times we do the mistakes in the easy question only. S dash derives dot s comma dollar. So this is about CLR of 1. Dot after s. So add every portion of s. S has two productions, A and epsilon, which is dot. S after nothing, so dollar and here dollar. and dot after A. So add every portion of A. A has only one production, which is dot A, and A after A. So this will be the first state. First state. So on S it is single, and it is final item. Final items look ahead. Look ahead is dollar. Dollar will never match with any of the symbol in the production. So there is no shift reduce and there is no reduce reduce. For reduce two final items has to be there. For shift reduce one final production, and final productions look ahead must be matched with any of the shift symbol. No. So here on dot A, this is already this is end, and this is on single A, it is on A it is single. Then on capital A, what will be this? Yes, there is A dot A comma A. So it is single production in this state, and after this on A also single. So there are no chance of conflict. So this is CLR of a grammar. It is true. It is a true statement. It is a true statement. So very few has given the answer. Okay, I think you need time. Yes, Kundan Kumar and Shubhi Goyal, Abhirup Sen Gupta, Ansue Mahapatra, Madhav Mishra, Amrita Yadav, yes, Yogita Chand, Rasika Mishra, yes. Yeah, Kundan Kumar, you can say that it is LL of 1, every LL of 1 is also CLR of 1. Of course, you can say like that also. Okay, but it is CLR of 1. Next one. The grammar is ambiguous grammar. Let me check. Yes, there is AAB, A place, I will go for AS, and S place again I go for AAB, and A place I will go for epsilon, and B place I will go for A place epsilon, and see B place AA and A place epsilon, B place AA and A place epsilon. So what is the string here? 1A, 2A, 3A, 3A, 4A, 5A. So 5 A's is the string derived from this parse tree. Okay. So AAB this production, and A place AS this production, S place AAB, then A place epsilon. Okay. Then B place AA and A place epsilon, B place AA, A place epsilon. Okay. Now can we construct a different parse tree for the same string? So let us check AAB and A place epsilon. A place we can go for epsilon, and B place AA and A place AS. Okay. S place AAB and B place AA and A place AS. So already we got 3 A's, and S place AAB and A place epsilon, B place AA and A place epsilon. So how many A's we have? 1, 2, 3, 4, 5. Here also 5 A's, but the strings are same, but trees are different. Therefore, it is ambiguous grammar. So both S1 and S2 are true. So 14th one, A is the option. A is the right answer. Okay. Okay. So that depends. So you may get a simple question, simple string, then this 5 A's. Okay. Anyway, this is CLR of 1, this is ambiguous grammar. So 14th answer is A. We'll go for next question. So this is simple question. So give me the answer. The minimum number of nodes and edges in the DAG for the following code segment. This is the code. 15th. So do it carefully, easy question. Oh, so different answers, 3 students has given 3 different answers. So always follow the bottom up approach, you will get the best answer for this. Okay. So check your answer here. So I'll go for this approach. So A equal to D plus C. After this C. So C, in C place I will apply B minus A, okay. C equal to B minus A. After this B. So in B place I will apply D plus C and minus A, okay. This is minus A. After that go for D. Next bottom up approach D. What is D? Here we have 2 places, D in 2 places. So A minus B plus A minus B plus C minus A. So any possibility of cancellation here? Yes, plus A and minus A, okay. After that A. So in place of A, only, so I repeat here, this is A minus B plus C na. So in place of A I will write B plus C minus B plus C. So plus B minus B. So what will be this? C plus C minus B. So C plus C. How can we write C plus C? C plus C. So one node C plus C, okay, C plus C minus this is B. So C plus C minus B. So how many nodes? 1, 2, 3, 4 nodes. 4 nodes. And how many edges? 1, 2, 3, 4. 4 edges. So simple question, why you are giving different answers? Okay. So Madam Mishra, your answer is wrong. So do it carefully. I know that you do very good. So I remember you used to give the good answers in the class, and Saloni also. So finally we have substituted, na? So this is the answer. So check this one, Saloni. So this is the final answer. This node itself A. This node itself A. So multiple statements, we don't take the equal operator. I told you in the class. Okay, I think that is the reason you got the wrong answer, Saloni. Okay, the 4 and 4 is the answer. Next. So this is the question. The number of nodes and edges in the CFG for the following code segment is. So this is the code. So I'll take give the numbering. This is 1, this is 2, this is 3, this is 4, 2, 3, 4, this is 5, this is 6th one, 7, 8, this is 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have given the numbering, it will be easy. I didn't get any answer till now. So find the leaders first. Find the leaders first. Anusuya, where is your answer? Madhav Mishra, Kundan Kumar. Kundan Kumar, what is the question here? Number of nodes and edges, not leaders. So where are you, Ritu? Vinay, Sohana, Anshu Mahapatra, is your answer right? Check once. Sardak Pal, Suri Goyal, 8 notes, 7 and 6. Okay, give me the answer then. Yeah, Ishwar Mahapatra. Okay, give me the answer, Ritu. Oh, why I am getting different answers for this question? Kundan Kumar, if we 8 notes, then what about the edges? Soumya Nandi, crazy, Aman. Okay. So first of all, I'll find the leaders. First is a leader. First is a leader. Okay. First statement is a leader. Then go in the sequence. So the target of go to L1. L1 is a leader. Then after that the statement that comes immediately after go to is a leader. This is a leader. Okay. So go to L1, target is a leader. After that go to is a leader. Go to L2. L2 is a leader. Go to after whatever comes immediately, it must be a leader, but already it is a leader. Okay, I repeat, L1 is a leader and this is a leader. L2 is a leader. After that it is already leader. So go in the sequence. Go to L3. L3 is a leader. After this it is a leader. Okay, so we have 6 statements, 6 leaders, 6 leaders. So here 1, 2, 3, 1, 2, 3. So 1, 2, 3 will be one basic block. 1, 2, 3. 1, 2, 3 is one basic block. Then 4 is one basic block. Here see 4 and 5. It is a jump statement. So here 1, 2, 3. This is one basic block, and 4 is one basic block, and 6 is one basic block. Then 7, 8, 9, because 10 is 7, 8, 9 is one basic block. So I am writing 4 is one basic block. Then one second, I did a mistake here. 4 comma 5. This is because yes, 4 comma 5 is not, so it is go to na, yes, 4 is only leader. Then that is only the statement in the basic block, then 6 is one basic block. Okay, so 4 comma 5 actually, but 5 is a jump statement. That is the reason I am taking only fourth statement in that basic block. Next, 6 is alone one leader, 6 statement is alone one basic block. Then 7, 8, 9. Okay, then 10, 11, 10 comma 11, then 12 comma 13, okay, and you know that very well, there will be a start node and there will be end node. So these are the nodes. How many nodes? 1, 2, 3, 4, 5, 6, 7, 8. 8 nodes. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Then start to here 1, 8. 1, 2, 3. If condition is true, if A is greater than C, then after third one go to L1. Where is L1? 6. So after third it go to the sixth statement. Are you following? 1, if A greater than C, in the third statement if A greater than C, go to L1. Where is L1? Sixth one. So from third it will go to sixth. Suppose condition is false, then come to fourth statement. Okay. After 4, it don't go to the directly 4 after 6, it never go to the 4 after 6. So after 4 go to directly jump to L2. What is L2? L2 is 7th statement. So after 4 it jumps to 7th statement. Now, okay, 6 after definitely it will go to the 7th statement. Then 7, 8, 9. So 9, if D greater than C, go to L3. So 9 after L3. L3 is what? 12th. 9 after it is 12. Okay, suppose condition is failed, then it comes to 10. Then 10, 11 after 12, then end. So this is the control flow graph. How many edges we have? 1, 2, 3, 4, 5, 6 and 7, 8, 9. 9 edges. 8 nodes and 9 edges. This is the right answer. Very few has given this answer. 8 Kundan Kumar, good, and Subi Goyal, good, and Madhav Mishra, good. Okay, so good guys. We'll go to next question. Okay. Simple question, you can do this within seconds. Go to statement, I never told you go to statement is a leader. The target of go to is a leader and the statement which comes immediately after go to, that is a leader. Seventeen. Rohit Kumar, Kundan Kumar, Ritu. So check your answers please. Easy questions guys. Rasik Mishra, good, it is direct, I need not to wait for this question. So here S derives AB, S derives AB, this is, and A dot value, child value, we are finding from right side of the sibling. Whenever you are finding from right side of the sibling, so whenever you are finding the child value, first of all it is not S attributed definition, because S attributed definition is synthesized, means you have to find the parent value. Here we are finding the child value, A is the children, and whenever you are finding the child value either from the left side siblings and or from the parent, then only it is L attributed. So here A dot value finding from right side of the sibling, so it is not L attributed and not S attributed. Okay. So this is not, this is not, this is not, answer is D. Simple. You need not to check the others. Okay. Simple question. So I have observed many times in the for the simple questions only you are giving the more wrong answers. The total number of variables in SSA form for the following code segment. The total number of variables in the SSA form for the following code segment. So SSA form, every statement must be assigned to a different variable. Read the question, Ishwar Mahapatra. Many times you are giving I think you are not reading the question properly. So earlier also you have done same mistake. So don't do these kind of mistakes in the examination, mister. Okay, be careful. So read the question properly. I have not asked you the total number of temporary variables. I have asked you total number of variables in SSA form. Good, good. Simple question. Simple question. Very good. So I need not to wait for this question because you know very well. Okay. So every time the left side must be made to different assignments. So different variables. So this is A1, when this is A1, this also will be A1, this is B1 because we have 2 B's and 3 A's. So that is the reason I am separating, this is A1, this will be A1. If this is B1, this will be B1 and this will be A2 and this will be A2. Okay, this is B, which B? This B, so B1 and this is B2 and this will be B2. And already A2 is done, this is A3. So anyway, you need not to count this, already these 5 statements will be 5 different variables, 1, 2, 3, 4, 5, 5 variables, 5 plus on the right hand side X and C, Y, A1 already counted, X is counted, B1 counted, A2 counted, B1 counted, Y already counted, B2 counted. Okay, so 1, 2, 3, 5 plus 3, this is 8 is the answer. 8 variable is the answer. Okay. So I gave you one question based on the liveness analysis. So 19th question. Do it carefully. So simple question. I told you the shortcut also. You need not to go to the procedure. Yeah, I know that you have given the answer for temporary variables, Ishwar Mahapatra. But in the examination, if you do the same mistake, okay. Consider the following control flow graph. The variables that are live in both block 2 and block 4. Block 2 and block 4. So here A, B, C, D, A, B, C, D, and also E, and also F. Is there anything else? No. So these are the variables, and 1, 2, 3, 4, 5 blocks. 5 blocks. Okay. Now, so anybody answer? Good. Here also I am getting the different answers. What happened to you all? So do it carefully. Answer that the number of variables, the variables that are live in both block 2 and block 4 means common, whatever common, the variables that are common in live in at block 2 and block 4, common variables you have to give the answer. Okay, let me explain this. So here first one, so block 1, so I am checking for A. So when if in the statement a variable, if it comes first on the right hand side, I told you it is live variable. If it comes on the left hand side, I told you it is dead. If it is on both left and right, then it is live. Okay, so A, first statement, it is on the left hand side, it is dead. So B, I am checking for B. B is on the left hand side, but before this statement B is on the right hand side. So whichever comes first, right side is coming first, so you have to consider, so it is live. And C, yes, live. D, here no, here no, here we have in both places left and right, so both places left and right, it is live only. Then E, nowhere, nowhere, nowhere. When a variable is not present in that block, then go to the consequent, go to this path. Next is block 2. Block 2, E, it is there on the right hand side live, and come to F. F is no, no, no F here, and here also no F, here also no F. Then go to the next path. You go in this path, F is present, or go in this path, F is present. So whichever comes first. So in this path it is dead, but in this path here it is coming this path first. Na? So before coming to this, it is coming to this one first. So F, it is on the right side live. Okay. Next come to 2. Here 2, the second block. A on the right hand side, it is live. B, it is coming on the right hand side, but before this it is there on the left hand side. So whichever comes first, so left hand side is coming, so it is dead. Then C, nowhere, here it is dead. Then D, it is not here, it is here. D, it is right side. Next E, yes. F, it is not here, and in this path it is. Okay. Next one, third. So I need not to do this in the question. Actually we can, they have asked about block 2 and block 4 only. You do 2 and 4 only, you need not do everything, but I am explaining because some of you may not know, that is the reason I am explaining this. So block 3, it is on both sides. A is right, left side and also right side, it is live. B is live. C, it is not present here, it is not present here, then go to next path, it is not present here, then go to the next, this sequence, this path. So what is this path? B3, then B5. So B3 C is not present, B5 C is also, in B5 also C is not present, then B5 after, where it is going? B1. So B1, go to in this path, then B1 to B2, then B2 to B3. You can, so B2, so B2 to this B3. So I am coming to say this is B3, okay, this is B3. So this is the sequence you can say B3 to B5, B5 to B1, B1 to B2, B2 to B3, this sequence. So we are checking for C, C is not present here, C is not present here, then go in this sequence. So C is on the right hand side, so it is live, then D, where is D? D is not present here, D is not present here, then go to this next, not here, it is both, it is live, then E, not here, S, it is here, it is live, F not here, but F here on the left hand side, it is dead. Okay, now block 4, this one, I will do the 4 and I stop the 5 because I want only block 2 and block 4, and block 4, here A is nowhere, then come to the next level, next block, A is on the right hand side, it is live, and B is nowhere, then go to, what is the sequence here? B4 to B5 to B1 to B2, then B4. This is the path. So in B4, B is not present, in B5 is not present, then go for B1. Yes, it is on the right hand side, and C, it is not here, then in B1 it is on the right hand side, and D, in D, yes, we have on the right hand side, and E on the left hand side, and F on the right hand side. So this is, what is the question here? Present the live the variable that are live in both block 2 and block 4. So what is the answer here? Here block 2, A is present in both 2 and 4, and D is present, and F is present in both block 2. Here B present but not present, here C present but not dead, means here it is live, it is dead, it is live, dead, here it is live, here it is dead. So what are the variables that are live in both block 2 and block 4? A and D and F. So A, D, F is the answer. So that is D. D is the right answer for this question. Good. Many of you have given answers, correct answers. Very good. Next we will go to next question. The following code has loop invariant optimization, copy propagation, common sub-expression elimination, loop fusion. Loop invariant optimize, loop invariant means any expression if you are evaluating multiple times, where if its value is not changed multiple times in the loop, that expression you can write outside of the loop, either in the before the loop or after the loop. And copy propagation means instead of one variable we write another variable. Common sub-expression elimination, same expression if you are keep on evaluating multiple times, that you can avoid it. Loop fusion, merging several loops into one loop. Do you find loop invariant? Do you find loop invariant here? Very good. So this question also I am getting different answers. So do it carefully, guys. Do it carefully. Easy question. Okay, good. So I'll go for the solution. Okay, look at this. Loop invariant. When I equal to 0, this I equal to 0 to n, a equal to b into c plus I value anyhow, it depends on I value, so you cannot write outside. But b into c always constant. Na? In this loop, are you changing anywhere b value? Are you changing anywhere c value? But as long as this for loop is executed, b and c values are constant, but every time this for loop executed, b into c has to be executed. So instead of this, what we do, we take some different variable. So let it be some, okay, p equal to b into c, some new variable, b into c. So here b into c we evaluate once, then instead of b into c we write instead of this one we write a equal to p plus I. So it need not to evaluate b into c multiple times. That is one thing. And the here also b into I. So when I equal to 0, then when I equal to some value, so this j loop will be evaluated, run n times, 1 to n, okay, n minus 1 times. So every time it has to evaluate b into a, because I is constant. Na? For a j equal 1 to n, I is constant. Here also you can write outside this loop. So there is a loop invariant option. Loop invariant optimization is there. Okay, next, copy propagation. Where is the copy propagation? Can you replace one variable with another variable? So no copy propagation here. No copy propagation. And next, common sub-expression. Yes. A into j. So j value is constant, a value is constant. You are not changing the a value or j value, but multiple times you are evaluating a into j. So you evaluate once only, a into j. That value you use here. So common sub-expression is also there. Then loop fusion. How can you merge the loops here? So there is no chance of merging the loops, so there is no loop fusion. So A and C is the answer. A and C only. Some of you has given A and C, it's good. Okay. That's all, guys. These are the questions. Some questions I have covered on both subjects TOC and CD. So thank you and all the best. So don't do any silly mistakes. If the question is simple and easy question, if you feel in the GATE examination, so you do more carefully. Okay, there is a lot of chances of doing the silly mistakes. Okay, all the best. Okay, thank you.